Good evening, everyone.
Good evening, ma'am.
Good evening, ma'am.
Good evening. Good evening. Okay. So, only 6 students. Okay. So, have you gone through the lectures of week 12?
Yes, ma'am.
Yes.
Not
Okay.
so much, ma'am, but today is the submission day, so we have to go through like so fast. I don't understand so many concepts there.
Mm-hmm. Yeah, it's just a simple thing. If you have understood week 11,
Yes.
yeah, then week 12 is easy. Like it's nothing. So, in week 11, we learned about Z test, right? So, in week 12, we will be learning about the other tests, which are like T test, chi square, F test, two sample Z test, two sample F test, like that. Okay, so we'll be just learning about the test. Okay, okay, so shall we wait for a few more minutes and then start the session, or should I start the session now?
Yes, ma'am, we can wait for 5 minutes.
Yeah, just let's wait for 5 minutes. Let's wait for other students as well. Okay, let's start with the session now. Okay, so in week 11, we learned about the Z test, right? So, when did we do Z test? For the sample mean, correct?
Yes,
Yes
ma'am.
or no? Yeah. And in this, we have a known variance, correct?
Yes.
Okay, fine. So when we are doing the hypothesis testing or something, what are the steps that we do? The first step is we have a null hypothesis and an alternative hypothesis, correct? Then the
Yes.
second step is what? We have a test statistics.
Yes.
Okay, we have a test statistics which is T. Okay, then we have a test which is we reject the null hypothesis when,
If T
yeah, if
T
T is
greater
greater
than
than some
C,
C. And what is this C? C is some critical value, correct?
critical value.
Yeah,
Yes.
so this is my the steps that we do in the hypothesis testing. Then we calculate the
Ma'am,
value
I
of C
have
by
another question
alpha.
here.
What is alpha? Alpha is reject
Probability of rejecting
H
H
naught.
naught when H naught is true.
H naught is true. Okay. So with this, we calculate the value of C and then we compare if we have got the value of some value of C, we compare it this with T. So if T is greater than C, we say that we are rejecting the H naught. If T is less than C, we say that we are accepting H naught. So these were the things that we did in week 11, correct? Now,
Yes.
in week 12, we have different kinds of tests. Okay. So the first test is T test. Okay. So when do we do this t-test? T-test is done when we have an unknown variance. Okay.
Unknown variable means X is unknown, right?
No, no, unknown variance. So let's
Oh,
suppose
sorry,
I
sorry.
am saying,
Unknown variance. Okay.
yeah.
Sorry.
So if I'm saying that my x1, x2, xn is following an IID sample with a distribution normal mu comma sigma square. Now this sigma square is unknown to us. Okay. So when sigma square is unknown to us, we use t-test. Okay. So the same thing. So my alternative would, sorry, and the same thing, my mu would be, my null hypothesis would be, if my mu is equals to mu naught, correct? Okay. My alternative would be, if my mu is greater than mu naught, or if mu is less than mu naught, or if mu is equal,
Not
not
equal
equal
to
to mu naught. So these
mu
are
naught.
the some of the alternative hypotheses. Fine. Now the second thing is, we will be having the test statistic. Now here my test statistics would be what? The sample, because we are like we are testing for the mean only, but in this case my variance is unknown, right? So my test statistics would be x bar. Now what is my test here? My test would be reject h naught if t is greater than c, or you can say if my t is less than c, or if my mod of t is greater than c. For all of the cases, if alternative is mu greater than mu naught, then my t is greater than c. If my mu is less than mu naught, we say t is less than c, or if it's mu is not equal to mu naught, we say t mod of t is greater than c. Okay, we say that. Now what is this? So now fourth, we will calculate the value of c. So my alpha would be what? Probability of t greater than c given my h naught is true, correct?
Yes.
Now what we have to do, we have to make it like a we have to standardize it, right? So for a t distribution, my value is t minus mu naught upon s divided
Divided
by
by
under
root.
root n. So this is following t distribution with n minus 1 degree of freedom. So if you remember in the z test, what we did in the z test, what it was? It was t minus mu naught divided by sigma, right?
Yes.
Which is following a no,
Ma'am, sigma by root n.
sorry, sigma by root n, right? Sigma by root n, which is following a normal distribution with 0 comma 1, correct? Now but here in this we don't have the variance, so what we use the sample variance, right? So if I'm using the sample variance, so t minus mu naught upon s upon under root n will be following t distribution with n minus 1 degree of freedom, correct? So my next step would be what? If I have to standardize it, it will be probability of, I will be subtracting mu naught divided by s upon under root n greater than c minus mu naught upon s upon under root n, correct?
Ma'am, are the values same as the normal, I mean standard normal table, or are they different?
No, no, it's different. So it will be a t table, like it's a t distribution, right? So this will be a t. They will be using table. Okay.
Okay.
Now
And
this will be
how
what?
does the distribution look like normal?
Yeah, it will be normal, like kind of normal. So this will be mu naught.
Ma'am, can we interpret this from the table given in the question paper, or the other way? If I say, if you can help us to just illustrate how do we interpret this table sometime maybe today,
Sorry,
of a graph, ma'am.
can you just repeat once
I
again?
mean, so for
In
all this
PYQs,
distribution, we see that
uh, table will be given, I guess.
Like the values will be given. Like we will do some questions, then we will get to know. Okay. Okay, so this is
okay, sure.
probability of t n minus 1 greater than this. Now this can be written as 1 minus probability of t n minus 1 less than c minus mu naught upon s upon under root n. Now I can write this as 1 minus f t n minus 1 c minus mu naught upon s upon under root n. Now this will be my alpha. Now you have to calculate by putting the value of alpha, then you have to calculate the value of c, and then you have to see if my t is greater than c or less than c, something like that. Then you will be rejecting the null hypothesis. Is the t distribution fine?
Yes.
Sorry.
What is here? What is the value of yes here?
S is the sample standard deviation. Okay.
Then why
Is
do
it
we
fine?
do a
Hmm?
why do we divide it by root n? Because when we take the population standard deviation, then
Yes.
we divide by root n generally.
Yeah,
But here,
because my
if we
test
take
statistic is what's the sample mean, right? So we are testing for the sample mean, right? So my sample mean would be following what? With what will be my expectation of sample mean? It will be mu naught, and my variance would be what? S upon under root. Instead of like the known variance, if my variance is known, I would be using sigma, right? If I don't have the variance, I would be using the sample variance, which is S. Okay,
okay,
is it fine?
okay.
Yeah. Okay, so is the t-test clear to you how to do it?
Little bit.
Okay.
I
Yeah,
understand actually the same thing, but here the formula is different.
yeah, the formula is different. Here, what we are using this term, which is t minus mu naught upon s upon under root n. This will be following t n minus 1 degree of freedom.
But
This,
basic is same like Z test only.
yeah, you just have to standardize it. Okay.
Okay,
So you
okay.
have to remember this thing. Like this will be following t distribution with n minus 1 degree of freedom. So you have to convert this thing, this probability, into this form. We do the same thing in the Z test, right? So we have a sample, we have to convert into a normal distribution. What we do? We subtract it with the mean and divide it by the standard deviation, correct? That's the same thing that you have to do in the t distribution. Okay, t test. Now,
Ma'am,
next
one
we
small
have,
query. So, can you please prove that S by root n is the standard deviation of t? Is it possible to prove it?
see, no. The thing is,
If I use the formula, will I get S by root n?
no,
Like
no, no. See,
x1,
listen.
x2.
My test statistic is what? X bar, correct? My X bar is my test statistic. So my X bar is following a normal distribution with mu comma sigma square by n. Correct? This is my variance,
Yeah,
right?
correct.
So what we do, so if I have to normalize it, if I have to standardize it, what I do? X bar minus mu upon sigma by under root n. We do this, right? This is following normal 0, comma 1. Correct?
Yeah.
So in the same way, if we don't have the variance, this thing is unknown to us. What we do? We use S, which is x bar minus mu divided by S upon under root n. Now this, if I'm using S, then this will be following t distribution with n minus 1 degree of freedom. Got the point?
Okay.
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 Yeah.
So S is the standard deviation of x bar, but we do S by root n, so that we get t n minus 1 distribution.
Huh.
Right?
Okay.
So, okay, S is the standard deviation of x bar. Am I right?
Yes.
Okay. But in the previous case, the standard deviation of x bar was sigma by root n.
Because at that time we knew the variance.
Okay.
We knew this value. But if we don't know this value, we would be using S, that is the sample standard deviation. Okay?
Okay. Okay.
Yeah. Now, similarly, we have a chi-square distribution. Chi-square test, basically. Okay? So what is chi-square test? If you want to test the variances, okay? If my variance is equal or not, okay? So let's suppose x1, x2, xn are IID samples following a normal distribution with mu comma sigma square. Now here my sigma square is known to us. Okay. Now here my null hypothesis would be if my sigma is equal to sigma naught. And my alternative would be if my sigma is greater than sigma naught. Or you can say if my sigma is less than sigma naught or sigma is not equal to sigma naught. So this will be my null hypothesis. So chi-square test is used for the variance. Like in Z, we use the test, like we use Z test for the mean and T test for the mean. Similarly, we use chi-square test for the variances. Okay, so this would be my null hypothesis, which is sigma equals to sigma naught, and this will be my alternative hypothesis. Okay, now here, my test statistics would be, which is T equals to S square, okay, which is my sample variance. Okay, and what is the sample variance? Sample variance is summation of xi minus x bar whole square divided by n minus 1, correct? Yes or no?
Can you repeat this, ma'am? Sample variance, this is right?
Hmm.
Yes, yes, yes. We learned it in week 3 or 4, I guess.
Yeah. So,
Yeah.
so chi-square test, we test for the variances. Okay. So my null hypothesis would be sigma equals to sigma naught. An alternative would be sigma greater than sigma naught or less than sigma naught or not equal to sigma naught. So these are my hypotheses. Okay. Then the second thing is we have a test statistics, which is S square, which is a sample variance. So in T test and Z test, what were my samples? Test statistics, it was the sample mean, correct? X bar. Similarly, we are testing for the variances, so we will be using the sample variance. Fine? Yeah. Now, what will be my test would be? Reject reject H naught if S is greater than some C, which is the critical value. Or you can say if my S square is greater than C square.
Okay.
Okay? Now, you have to remember, if my X bar is following a normal with mu comma sigma square by n variance, then n minus 1 S square divided by sigma square will be following chi-square distribution with n minus 1 degree of freedom. Okay, so this value follows a chi-square distribution, correct? Now, the same procedure we would be doing. Now we will be calculating the alpha. So alpha would be probability of reject the H naught, that is my S is greater than C given my H naught is true, right?
Yes.
So probability of what is my, so I have to convert this into this equation, correct?
Yes. So
Right?
A square greater than C square.
Yeah, so this will be S square greater than C square given H naught true. Now this will be probability of, I would be multiplying n minus 1 both sides and dividing it by
Sigma square.
Sigma square, which this will be greater than n minus 1 C square divided by sigma square,
Sigma
correct?
square.
Till here it's fine?
Yes.
Yeah. Now this will
H
be
naught
what?
means sigma is equal to sigma naught.
Sigma equals to sigma naught. So in the place of sigma, so this will be sigma naught. Okay. Now this will be what? This is chi square n minus 1 greater than n minus 1 C square divided by sigma naught square. Fine.
Correct.
Now I can write this as 1 minus F chi square distribution with n minus 1 C square divided by sigma naught square.
Sigma naught square.
This will be my alpha. Then the next process, you have to calculate the value of C by just equating the equation and everything. Is this thing clear? Chi-square is clear? Yeah, I know that you have to remember these values, but other than these values, is the method clear?
Yes, method is clear. I have a question actually.
Yeah.
So, in some previous year, I don't know which year, all the tables were mentioned. Okay, in question paper. In
Tables in the
2020.
sense? Which
Sorry.
tables? Which tables?
Okay, there are tables called a test hypothesis testing. There are Z test table. like their test name, H naught, HA, what is that, like test statistics, rejection region, all things are present. 2023 question, 2024 question. I'm not sure about that they will provide it. What my
No,
doubt
even
is
last year it was there. Last year also it was there. I have checked. That is where I'm just. That's what I was telling, ma'am. If you can just help us to interpret what the table means, that will be of a great
Can
help.
you just share me
I
what
will. I will.
table?
I will.
Yeah, just
I
share
will.
me that.
Let me share, madam.
what you tell
Huh.
now, that is only written in here, but what my doubt is, my week 11 is not crystal clear to me. That's why I ask, whenever there is right tail test or
Hmm.
left tail test or two tail test, alpha will be
Hmm.
same.
No,
No, no, okay, okay.
no. When we have a two-tailed test, we would be using alpha by 2.
No, here when you are writing
Hmm.
that it's greater than C, given that H naught. So
Ha.
we got some alpha. So when
Ma'am,
we are,
this is the table. If you can see
yes,
what
is
she.
that's what I'm telling. These tables are provided in question paper.
Yes. So this is
Do they
there.
Uh,
provide this?
Yes.
I'm
Yes,
not
ma'am.
sure.
Yes.
Okay, yeah. If
no,
they provided, then fine.
last three question paper I saw they provided this.
Okay, so
Yeah.
what's the
So,
issue in this?
no, I just got confused. How do I use it, or how do I interpret this for this kind of a question, right? I mean, if this table is given, if
Hmm.
you can just help us to interpret this particular table, that will be of a great help. I just want to read this table. That's it.
See, it's the same thing that I told you. So this is for hypothesis test for mean when population is known to us. This is Z test. Okay, let's go with the T test. Okay, so T test is what? I'm going with the right tail. Okay, so what is the right tail? When my null hypothesis would be mu equals to mu naught, and alternative will be mu is greater than mu naught. Now, my test statistic would be what? T equals to x bar and then T n minus 1. So it's the same thing that I told you here. See,
So,
same
ma'am,
thing.
the first column, that is the Z test. If you see the right tail test, H naught and HA is clear, then the test statistics, right? Now, in this T is equal to X bar. Now, this
Correct.
is the standardization formula you mean to
Correct.
say, right?
Yes. Yeah.
Okay, okay, okay.
Okay. And my rejection region would be what? My x bar is greater than C.
Okay, and would it be different for normal and binomial separately like this, or it will be the same for all the kind of a distribution?
This is for Z test, basically. Then we have a T test. So it's like distribution is a different thing and test is a different thing.
No, I have a test where my IID samples are distributed normally, or it's a binomial distribution.
Oh, okay,
So,
like that. Yeah.
yeah.
Hmm. So in that binomial, then you have to change it to the Z test or according like normalize it. Then you have to use the Z test or the P test or the chi-square test, something like that. So,
Oh,
but from the
okay.
binomial only, you will be getting to know what's your the mean and the variance, right?
Acha.
Ha. Okay.
Okay, ma'am. Okay, I'll stop sharing.
Yeah. So yeah, so this is what the table is trying to tell you. Okay, so we have a t-test. In that t-test, I have a null hypothesis. I have an alternative hypothesis. So in that so in all the right-tailed or the left-tailed or the two-tailed test, my null hypothesis would be same. Okay. Now my alternative would be what? This is for the right tail. This is for the left tail, and this is for the two-tail. So these are my alternative. Now, the test statistics, what would be? We are testing for the sample mean. So my test statistics would be the X bar, the sample mean, correct? Now, my test, what would be my test? I would be my rejection area. So my rejection area would be what? If it is a right tail, my T is greater than C. If it's left tail, my T is less than C. And if it's like a two-tail test, my mod of T is greater than C. Okay? So these are the same thing. Then my z, so they are just telling you what is my t n minus 1. It will be t minus mu naught upon s upon under root n. So this value is following a t distribution with n minus 1 degree of freedom. That's it. Okay, that's the table is like trying to tell you the values and everything. Is
Okay.
it fine?
Yes, okay, ma'am.
Yeah.
Got it.
Okay, so my chi-square is what? The chi-square test is used for the variance if my x1, xn are IID with normal mu comma sigma square. This is my null hypothesis. These are my alternative. Now here, the test statistics would be what? I am testing for the variance, right? So my test statistic would be what? The sample variance. Fine. Now my rejection region, what would be my rejection region? My rejection region would be if my S is greater than C, or you can say if my S square is greater than C square. Then you will calculate the value and S square, just convert it into a chi-square distribution. Then you have to calculate the value of L, calculate the value of C.
Ma'am, the only problem that I see in this is the normalization or standardization wala part. Rest
Ah,
everything is very clear. But for standardization, for different tests, we have different and also
different thing. Huh,
okay.
that I got it. So you just have to remember what test you are using. If you are using t test, then you have to standardize into this form: t minus mu naught upon s upon under root n. If you're doing chi-square, you have to standardize into this form. Like you have to convert this, you have to make it into a chi-square distribution. See, if you look here, this what distribution this is following. This thing is not following any distribution, right? So
Yeah,
you have to convert this into some distribution, either z, either t, or chi-square, f test, or something kind of like that. So you have, if you have to convert this, you have to multiply and divide the numbers. Then you will be having some distribution. Now this thing is following a chi-square distribution with n minus 1. Then I would be having some values. I would be having then I can have the f values for the chi distribution with n minus 1 degree of freedom. Then I can find out the value of C. So you have to convert that into some distribution, right? You
sure.
got the point?
Yeah,
Yeah. So the main thing is you have to remember which form is following which distribution. That you have to know. Fine?
sure.
Yeah. So the t test and the chi-square test is fine.
One small question again. So if in case, in the case of chi-square test, you used the right-tailed, just for this explanation in this step.
Hmm. Hmm.
But if in case when we use the
Tail.
left tail,
Yeah.
we
The
generally
sign
will
will
have
change.
yeah. So we usually will have yes less than minus C, right? So will the square of this inequality be the same when we use
No,
negative?
if it's like no, if it's like the left eight test, my S will my rejection region will be S less than C.
Okay.
Yeah. Okay.
Okay. Generally, will it not be minus C here?
No, no,
Or
no, no.
okay.
Because in the chi-square test, everything is we like positive thing. So my
Oh,
S, if my S will be greater than C with some critical value, or my rejection region will be, if it's left tail, so it will be C, like S will be less than some critical value.
okay. Because this is standard deviation, this will be positive always. Yeah. Okay.
Okay. Yeah. Then we have two sample tests. So these were for the one sample test. Now we have a two sample test. Okay. Now two sample tests in the sense like if I'm having x1, x2, xn is one sample IID which is following a normal with mu 1 comma sigma 1 square. Similarly, I'm having second sample y1, y2, yn IID which is following normal mu 2 comma sigma 2 square. Okay. Now for this, if I have for the two sample test, if I have to test for the sample mean, whether my two samples are having the same mean or not. So at this point, I would be having my null hypothesis as if my mu1 is equal to mu2. This is my null hypothesis. Okay. And my alternative would be if my mu1 is not equal to mu2. So this will be my alternative hypothesis. Till here, it's fine. In this case, my sigma square, it is known. If my variance is known, then we say it's a Z test. Okay. So now my null will be this, my alternative will be this. Now here, what will be my test statistic? Test statistics would be T equals to Y bar minus X bar. Okay. And my test would be, I would be rejecting H naught if my mod of T is greater than some critical value. Till here, is it fine? Is this fine?
Yes, ma'am.
Any confusion?
No, ma'am.
Okay. Now here, you have to remember that if my x1, x is following a normal with mu1 comma sigma 1 square, and my y is following normal mu2 comma sigma 2 square. Now, what will my y bar minus x bar will follow? It will follow normal distribution with, let's suppose like it's x bar minus y bar. So this will be following mu1 minus mu2 comma sigma 1 square divided by n1 plus sigma 2 square divided by n2. Correct? This will be my mean. This will be my variance. Yes or no? Okay, if I have to calculate the value expectation of x bar minus y bar, this would be what? Expectation of x bar minus expectation of y bar. Correct? Now, what is the expectation of x bar? Anyone?
It has to be mu1, ma'am.
Yeah, it is mu1. Okay, so this is mu1 minus what is expectation of y bar?
Mu2.
It is mu2. Yeah. So my expectation of x bar minus y bar is mu1 minus mu2. Got the point? How we got this? Now similarly, variance of x bar minus y bar. This would be what? Variance of x bar plus variance of y bar. Correct?
Yes,
Yes or
ma'am.
no? Yeah. So variance of x bar would be sigma 1 square divided by n1. Correct? Variance of x bar.
Ma'am, in LHS, you have written variance of x bar minus y bar.
So it will be squared. Right? -1 squared will be +1.
Do you remember this thing like variance of x plus y is what? If they are independent, it will be variance of x plus variance of y. Correct? Now, if it's variance of x minus y, I can write this as variance of x plus, I can write this as -1 of y, right? Yes or no? So this will be what? So this is variance of x. So this is one thing. Okay. So I can write this as variance of x plus variance of -1 into y. Now this is what? My constant term. So this can be written as variance of x plus -1 square into variance of y. So I can write this as variance of x plus variance of y. Now you got the point?
Yes, ma'am.
Yeah. So now here, what will it be? So this is sigma 1 variance of x bar plus variance of y bar. So this is sigma 1 square divided by n1 plus what is the variance of y bar?
Sigma 2 square by n2.
By n2. Now you got the point? My x bar minus y bar will be following normal distribution with mu1 minus mu2. This will be my mean and this will be my variance. Is this thing clear?
Ma'am, n1 and n2 are they equal?
No, no, no. They are different.
Okay.
Okay. So this x bar minus y bar, this distribution is clear. Yes or no? So now what will be my alpha here? My alpha would be probability of rejecting H naught. When are we rejecting H naught? When mod of T is greater than C, given my H naught is true. Correct?
Ma'am,
Yes.
now if we have two distributions, like will it always be the same distributions or it could be different
It will be same.
every time?
Yes.
Okay.
Okay, so my alpha is probability of mod of t greater than c given my h naught is true. Okay, now this will be what? Now I have to convert this into this form, which is okay. Now I have to convert this into a standardized form. So basically, when we had only one sample, so what we did, we usually did x bar minus mu naught upon sigma by
Sigma.
under root n. So this was following a normal distribution with 0, comma 1, correct? Now we have the two samples. What we will be doing? Now my t would be t minus. Now what is my mu naught? Mu naught will be mu1 minus mu2 divided by sigma 1 square upon n1 plus sigma 2 square upon n2 under root of this, correct? Now this will be following a normal with 0, comma like this. Let's suppose this is the this is some sigma square, sigma square variance. Is this part clear? T minus, this is the mean and this is the variance. Is this part clear?
Ma'am, mu1 minus mu2 can be any value. Why 0?
mu1 minus mu2 can be. So the alternative hypothesis, what the alternative hypothesis, sorry, the null hypothesis is what? I am considering my mu1 is equal to mu2. Okay. Yeah. So now this will be polynomial 0, comma sigma square. Is the equation clear? Give me a thumbs up. Or
The denominator, how, madam? So this could you please explain how the sigma square is came?
how this? Which one?
That sigma 1 square
No.
by n square, the square root, how you are how it's
Okay.
equal
So
to
if
square,
my
sigma square.
see, if my x square is following normal with mu comma sigma square by n, correct?
Yeah.
So if I'm like if I have to convert this, so I would be subtracting it to the mean and dividing it by the standard deviation, correct? Under root,
Yes.
correct?
Yeah.
Similarly, the same way. So t minus, this is my mean,
Okay.
and standard like the under root of the variance, and variance is what? This one, right?
Yes. Yes.
Yeah. So I just did the variance. So I'm just denoting this whole thing as sigma square. That's it. I'm just denoting it with some value. Yeah.
Okay.
Yeah. That is not sigma square.
But
I
but
just
it's not equal to sigma square. Your
no, no, no,
assumption
no,
you are
no.
taking.
I just say because like I just like so this will be following normal for 0, comma this whole value,
Whole time
right?
will be sigma square. Yeah. Yeah.
Ha.
Okay.
So
Okay.
instead of writing the whole thing, I just wrote it with sigma square. That's it. It's just a term.
Okay.
That's it. No,
Okay.
nothing.
Okay.
Okay.
Okay. Okay.
So is this
Hello.
thing clear? Yeah.
I have one question. So in this case, t is also a random variable, right? In this case, in this last equation, generally
Ha, ha,
speaking.
ha, ha. It is test
So
statistics. Yeah.
yeah. So then in that case, in this equation, what we have is t minus e of t divided by st of t. So according to central limit theorem, this should be this should follow the normal distribution
Normal.
of 0, 1, right?
Ha, ha,
Always.
ha.
But you wrote 0, comma sigma square. Why?
Yeah, because this is my variance, right?
But it has, according to central limit theorem, when we subtract the expected value and divide by the standard deviation of that random variable, then it should follow n of 0, comma 1, right? Not sigma square. That's the central limit theorem. Or
Like it should follow normal distribution. That's a central limit theorem, right? 0, comma 1.
okay. Yeah. Okay.
Yeah. So you are saying that that's like this thing is not following normal. So this should also follow with 0. Sorry, normal with 0, comma sigma square. Sorry, 1, right? You are saying that.
Yeah.
Yeah, but
Yes.
we are yeah. So but here we are using two sample, right? So for the two sample, my so if we are using the two samples, my mu1 minus mu2, this will be 0. This will be 0 only, but my sigma square will remain this, which is sigma t square. Sorry, the sigma square.
Okay. But in the previous equation, it was x bar minus e of x bar divided by sd of x bar, which follows n of 0, comma 1. So I thought it should be the same for t.
No, no, this won't be following normal 0, comma 1. This would be following normal 0, comma the variance value, which is the sigma square, like that. But I'll just check on it. Okay.
Okay.
Yeah, I'll just check. Okay. So what were we? Yeah. Now this is mod of t. Now I have to convert this thing into this value, right? So I have to make it into a like a like a normal distribution, correct? So this will be just a second. X square minus this will be common. This is 1 only. So this will be following normal 0, comma 1. Yeah, you're correct. This will be 0, comma 1.
Okay. Thank you.
Now I have to convert this value into the standard normal variable, right? So what I would be doing, I would be subtracting it with mu1 minus mu2 divided by the sigma, like the sigma value, which is this value, sigma square, greater than, similarly, c minus mu1 minus mu2 divided by the sigma square value, correct? Yes or no? So now this would be what? This is just a normal distribution, which is the z greater than c minus mu1 minus mu2 divided by the sigma square. Now I can write this as 1 minus f z c minus mu1 minus mu2 divided by sigma square. This will be my alpha. Is this step clear? Yes or no?
Yes, madam.
Yeah. Okay. So this is how we do the two sample test for like two sample z test. Okay. So z test is fine by everyone. Shall we move to the last test, which is the F test? Yes? Okay. Is everybody understanding the concept? Like, I'm not hearing yes or I'm not getting thumbs up at that. So I need to know. Then I'll just continue.
Yes,
Should we use sigma
understand
square?
the concept,
Sigma
but
Yes, Aditya.
Should we use sigma square here?
Sigma square, I'll just
Yes,
let me just check it with some other.
Okay.
So this will be under root of sigma 1 square divided by n1 plus sigma 2 square divided by n2. So similarly, this sigma 1 square divided by n1 plus sigma 2 square divided by n2. So this will be the same. Fine?
Yes, ma'am. Thank you.
Yeah. Okay. Shall we move forward? Any doubts still here?
one doubt is that previously we learned that Z test is the like test for mean, where sigma square is known. Same characteristics for two samples test also, right?
Yeah, correct. So in that case, we
Variance
had
is known.
one sample, but here we have two samples.
Hmm.
So we will be comparing the two samples now. Sorry?
Okay. Got it.
Yeah. Okay. Now here comes to the last.
Madam, the page one, maybe I'm late. Just is it possible to give the quick summary, the page one? So page one, what you explained to me?
From page 1.
Yeah.
Can I just, okay, let me just finish with the last test, then I will just go through the whole test once again. Okay? Yeah.
Okay, thank you, madam.
Now we have the F test. So F test is when we are doing F test, it is for the variances only, but when we have the two samples. Okay, so same thing, if my x1, x2, xn is following normal distribution with mu1 comma sigma 1 square, y1, y2, yn is following normal mu2 comma sigma 2 square. Now in this case, my f distribution would be what? If my s1 square means sx square divided by sy square will be following f distribution with n1 minus 1 comma n2 minus 1 degree of freedom. So this will be my distribution. So sx square, what is sx square? This is the sample variance, right? So sample variance of x divided by the sample variance of y will be following f distribution with n1 minus 1 comma n2 minus 1 degree of freedom. And this is the case when my sigma 1 equals to sigma 2. Then only we say that my sx square divided by sy square is following a f distribution with n1 minus 1 comma n2 minus 1 degree of freedom. Is this thing clear? What is f distribution?
Yes. That is
Yes.
H naught, right? Sigma 1 equal to sigma 2.
That is my h. So in this case, in the f test, what we do, my null hypothesis would be if my sigma 1 is equal to sigma 2, and my alternative would be if my sigma 1 is not equal to sigma 2.
Mm-hmm.
Yeah. Now, my here, okay. Now here, what will be my test statistics would be? My t would be if that is sx square divided by sy square. This is my test statistic. And my test would be what? I would be rejecting h naught if my t is greater than 1 plus cr, or if t is less than 1 minus cl. Okay, so now what is the cr and cl? Now for f distribution, this is my graph of f distribution, correct? Now this is my 1. Okay, so now when will be the value of t will be 1? When my null hypothesis is true, correct? At that point only my that the test statistics would be 1, correct? Yes or no?
Yes, ma'am.
Yeah. Okay, now I have to make a region in which I have to reject my null hypothesis. So what will I be doing? So this is my some critical value on the right side, and this is some critical value on the left side. So I can write this as 1 plus CR, and this is 1 minus CL. So my rejection region would be what? This region and this region. So these are my rejection region. So if my values are in this region, I would be rejecting the values. So that's why I said if I would be rejecting h naught if my t is coming 1 plus CR is greater than this value or is less than this value, then I would be rejecting h naught. Is it clear?
Can you also plot CR where it is? So it should be from
CR,
1 to
CR
CR,
this
right?
thing,
1 to
CR
CR,
this
right?
thing,
On
1
the
plus,
axis.
sorry?
Uh, on the x-axis, it should be from 1 to 1 plus CR, right? CR.
Yeah,
This
1 plus CR.
okay. Okay.
So this is my, this whole value, this thing, this point is basically 1 plus CR, okay? And this is 1 minus CL,
Okay.
okay? Yeah. So, so when we are doing F test, we would be rejecting H naught if my test statistic is coming out to be greater than this value or less than this value, then I would be rejecting the H naught. Fine.
Madam, I don't understand this. T value is one. That I don't understand actually. Please explain, madam. Actually, one how you fix it actually.
One, how one came. So I am just considering that so one is coming if my null hypothesis is true. If my null hypothesis is true, then this value will be equal to this value.
Then it will be one only. Okay. Okay.
Okay. Now, so we have to make a region in which I have to reject my null hypothesis. Okay. So I just made this region. So let's suppose I just take an approximate region. So this region, like around one, it would be like my null hypothesis will be true. Correct?
Okay. Yeah.
Yeah. I will take. So now after this region, this particular region, I would be having the rejection. I would be rejecting my null hypothesis. Correct? So what regions I am taking the critical values? If it's 1 plus CR and 1 minus CL. So if it is coming out to be greater than 1 plus CR, I would be rejecting H naught. Or if it's coming less than 1 minus CL, I would be rejecting H naught. Now got the point?
Yeah, got it, madam. Thank you.
Ma'am, why we are considering that CR and CL is different? Like, why can't we have a single parameter C to say 1 plus C and 1 minus C?
We are just because we are taking like one, we are considering one, right? So 1 plus some value that would be my some critical the critical like the values, right? So after that only I would be rejecting something, and 1 minus some point I would be rejecting the H naught. So we just took 1 point, 1 minus
But
something, and
we are
1 plus CR.
considering CL and CR to be different, right? In previous cases, like in the Z test, we used to take alphas like x minus mu less than alpha, something like that. Like alpha will be same on left and right directions. But here we are considering CL and CR to be different.
See, this is my critical values, right? And these are my significance value, alpha by 2.
Oh, okay.
So yeah, this is alpha by 2. So so this is like a two-tailed test, right? So if I'm having two-tailed test, my significance level, my rejection region would be divided into two, right? Alpha by 2 and alpha by 2,
Yeah.
right? If I'm having only one-tailed test, right, like right-tailed or left-tailed, then I would be having only alpha, right? So
Yeah.
if it's like a one-tailed test, this would be what? My alpha, this alpha would be equal to alpha by 2 would be equal to what? Probability if my t is greater than 1 plus CR, or if probability is t less than 1
Then
minus
1 minus
CL.
CL. Yeah.
Okay?
Yes.
Yeah.
Okay.
So this is my F test. Okay. Okay. So how will we be calculating this? So my alpha is what? Probability. If I'm taking alpha by 2, right? So if my alpha by 2 would be what? Alpha by 2 is probability t greater than 1 plus CR if my H naught is true, correct? Or we can say if my probability t is less than 1 minus CL if my H naught is true, correct? So if I'm taking this value, which is alpha by 2 equals to probability of t greater than 1 plus CR. Now I can write this as 1 minus probability of t less than 1 plus CR, right? Now I can write this as 1 minus F 1 plus CR. Now this is the F distribution, right? So this will be alpha by 2. Now you have to calculate. So I would be calculating the value of 1 plus CR. So 1 plus CR would be what? F of 1, F inverse of 1 minus alpha by 2. Similarly, if I'm taking the left hand side, so this will be probability of t less than 1 minus CL, which will be equal to what? So this will be F 1 minus CL. Now 1 minus CL will be equal to 1 minus F inverse alpha by 2. Okay, these are some values. So after calculating the value of 1 plus CR or 1 minus CL, I will be comparing it with the value of t. So if my t is coming out to be greater than 1 plus CR, I would be rejecting. If it's coming less than 1 minus CL, I would be rejecting H naught. Okay. We will do the questions. Just wait for a few minutes. Is the thing clear? Like the whole theory is clear? The concept? Yes or
regarding
no?
the concept, yes, regarding the concept, is it possible to have CL equals CR somewhere?
No, we can't have CL and CR equal, because if you see here, my point here, so this thing is like, it's not symmetric, right? So here I am having a different like value, and I will be having different value this side as well.
Okay.
Yeah.
So like in the previous cases, like in week 11, we were using the standard normal distribution, which was
Hmm.
symmetric. That's why it was 1 plus C, plus or minus C, something like that. Okay,
Yeah.
got it.
Okay. Okay. So let me just brush up once again. Okay. Like somewhat you got the idea. Yes or no? Give me a thumbs up or something.
This alpha
Yes,
by
ma'am.
2, how it's came, madam, actually. So I can able to understand this both sides equal, like that it's equated.
The region would be divided, right? So I'm having two regions, two rejection regions. So my first region is this thing, and the second is this. So either.
Oh,
So
okay.
my rejection region would be alpha by 2 and this is alpha by 2. If I'm only having one region, so basically
Okay.
what we did, we used to did if this is my value. So I would be having only one value, critical value. So this will be my alpha region, correct?
Yeah.
We would be taking that region, right? So if
Yes.
I'm having two tail test, what would be having? I'm having two regions, right? So this will be alpha by 2 and this will be alpha by 2, correct?
Okay. 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 Okay.
Yeah, same.
But
So now
here it
this,
is
my
not
two
equal,
regions,
right? In this area, it's not equal for
this is not equal.
F
My
test.
critical the CR and CL are different.
Okay.
That's
Okay.
why we are using CR and CL. Otherwise, we would have used C only, right? In most, like
Yeah.
in t-test, in the chi-square, we were using only C, correct? But here
Yes.
we
Yes.
are using CR and CL because the two values are different. Okay?
So, so the CL denotes left side like that, right?
CL is the left side and CR right side.
Okay.
Okay?
Okay, madam.
Okay, let's go through it once again. Okay, so the first thing is we have the t-test. Okay, when we do the t-test, we use the t-test for the sample mean. Okay, and the condition is we should not know the variance. If it's an unknown variance, we say we use the t-test. Now, if my x1, x2, xn is following a normal with mu comma sigma square, right? Sigma square. Now, in this, my sigma square is unknown. Then what I would be doing, my x bar, my t-test would be, t would be my sample mean, and I would be rejecting if my t is greater than some critical value. Now, this would be what? My t minus the mean divided by s under root by n. This will be following t n minus 1 degree of freedom. Is it fine?
Ma'am, why are we using n minus 1?
N minus 1 is the degree of freedom actually.
Can't we use n?
No. Degree of freedom in the sense, okay, so what is the degree of freedom? Degree of freedom is like the independent variables. Those are my degree of freedom. Okay. So in every case, we have n minus 1 degree of freedom.
Okay, ma'am.
Yeah. Okay. So this is the t-test. Now we have the chi-square test. What is the chi-square test? It is used for the sample variance. Okay.
Here,
And in this,
sorry to interrupt. C greater than C, sorry, T greater than C. The C denotes what, madam? Actually,
this is the critical value.
critical value. Okay.
Okay. So this is my sample variance. I would be testing for the sample variance. Now here my t-test statistic would be what? T is equal to my h square, and my rejection region would be what? If my h square is greater than some critical value c square. Okay. Now in this, which equation would be following my chi-square distribution? It would be n minus 1 into s square divided by sigma square. This would be following chi-square distribution with n minus 1 degree of freedom. Okay.
Ma'am, here is standard deviation.
Sample variance, or you can say sample
Sample
standard deviation.
standard deviation.
Huh. Okay. Then we have two sample Z test. Okay. So in this,
This equations are the normalization or the standardization equations, right?
which one? This one?
Yes, ma'am.
These are not like standard or something, but these are the forms, like these things is following some distribution, the chi-square distribution or t distribution, something like
Right.
that.
So the hypothesis, when we are standardizing it, that is where we are
Yeah,
using.
so we have to convert that point into some distribution, right? So if we are
Right.
converting that into some distribution, with the help of that, we would, like, with the help of the, so if you have to find out the values, right? So we would be using the tables, correct?
Okay.
So for
Sure.
that table, which table we have to use? First, we have to convert that probability into some distribution, right?
Right.
Yeah. So for that only, we just have to convert the that probability into some distribution. Then with the help of the like with that value, we would be seeing which table we have to use, right?
Okay. Yeah. Sure.
Now we have the two samples Z test. In this, my null hypothesis would be what? If my mu1 is equals to mu naught, and my alternative would be what? My alternative would be if my mu1 is not equal to mu naught. Now here my test statistic T would be what? My x bar minus y bar, and my rejection, like my test would be, I would be rejecting if my mod of T is coming is greater than some critical value, right? Now here, this would be what? My T minus x bar, sorry, this will be what? Mu1 minus mu2 divided by sigma 1 square divided by n1 plus sigma 2 square divided by n2. Now this would be following normal distribution with 0 comma 1, right? Now we have two sample F test. Okay. So when do we use we use this test? We use for the variances. Okay. To test whether the two samples are having the same variance or not. Right. So in this, my null hypothesis would be what? Sigma 1 equal to sigma 2, and my alternative would be what? If my sigma 1 is not equal to sigma 2. Now here my test statistic T would be what? Sx square divided by sy square. Okay. And my rejection would be what? If I would be rejecting if my T is greater than 1 plus CR, or if my T is less than 1 minus CL. Now you got the point? Now is it fine a little bit?
Yes, ma'am.
Yeah? Okay, let's solve one question. Now, here we have a question. Suppose X is following a normal distribution with mu comma sigma square with unknown sigma. So here I have been given that my X is following normal with unknown sigma. Now, N is 36 IID samples of X. The observed sample mean is this, and the sample standard deviation is 3. What conclusion would be? Okay, why we are using t-test here?
Unknown sigma square.
Yeah, because we have unknown sigma square. So if we have unknown sigma square, we will be using t-test. Okay. Now, if the null hypothesis assumed to be mu equals to 14, so if I have been given h naught, which is mu equals to 14, and alternative is mu is not equal to 14 at a significance level of alpha, or alpha is 0.05. Now we have to calculate, we have to conclude whether we have to reject the null hypothesis or accept the null hypothesis, correct? Okay, so can you tell me what, this is my first step, these are my alternate null and alternative hypothesis. Now what is my test statistic here? What will be my t here?
X bar sample mean.
Anyone?
Sample mean, ma'am?
Yeah. So my T would be what? X bar, right? Now the third thing is what would be my test? Test would be what?
If mu is equal to 14,
When I would be test is I would be rejecting H naught if
T is
uh,
greater than C.
alternative is a two-tailed test.
Total test.
Yeah. So it would be mod of T greater than C. Correct?
yes,
Till third step, is it clear? It's the same thing. We did week 11, we did the same thing, right? We had the null hypothesis, we had some test statistic, and we had the test. Correct?
right.
Yeah? Okay, fine. Then, fourth step, we would be calculating the values, right? So alpha would be what? Probability of what is alpha?
Reject H not given.
Reject H naught given H naught is true.
Reject H naught given H naught is true. Now, what is reject? When do we reject H naught? If my mod of T is greater than C, given
Yeah.
what is H naught?
H naught is not equal to 14. That one.
Huh? H naught.
Okay, H naught is
What is H naught? H naught is huh?
mu is equal to 14. Yeah.
Yeah. Okay. Now this would be what? Now I have to convert this. So I am using T test. So I have to convert this into a T distribution with n minus 1 degree of freedom. Correct?
Yes.
So now what is which equation is following T n minus 1 degree of freedom? It will be
T minus mu divided by sigma divided by root over
S
n.
divided by under root n. Correct?
Yes.
So I have to convert this.
N
So
minus
it will
1.
be, huh, eh, yeah. So this will be what? Mod of T minus mu naught divided by S upon under root n. Similarly, C minus mu naught divided by S under root n. Correct?
Yes.
Okay. Now just put the values here. So this will be what probability. Now this thing is what? Mod of T n minus 1 degree of freedom greater than C minus. What is mu naught?
Mu naught is
14.
Mu naught is 14 divided by what is my S according to the question?
3.
Yes. So this will be 3 divided by what is my N?
36.
36.
N is 36. Okay. So this will be probability of mod of T n minus 1 C minus 14 divided by 3 by 6. So this can be written as probability of mod of T n minus 1 mod of C minus 14 divided by 1 by 2. Correct?
Yes.
Now, this can be written as 1 minus f of T n minus 1 to C minus 14. Can I write it?
Why 2, ma'am?
Yes.
It's 1 by 2. Huh? So this would be what? T n minus 1, 2 into C minus 14. This 2 will,
Okay.
yeah. So this is my alpha, right? What is, and alpha is given 0.05. So this is 1 minus f T n minus 1, 2 into C minus 14. Now, I have to find out this C value. So this will be what? F T n minus 1, 2 into C minus 14. This will be 1 minus 0.05, which is 0.05.
95.
Now, this will be what? 2 C minus 14. F inverse of 0.95. T. Okay, now T with what is my degree of freedom here?
N minus 1, right?
Yeah.
N minus 1.
So this will be, what is N?
36.
This will be
35.
35. Now, according to the value that they have, 0.025. Some calculation is
Ma'am,
required.
Actually, there is a mod symbol, right? Like, how can you?
Sorry, okay, yeah. Correct, correct. Okay, so if this is like mod thing, right? So this will be equal to what? 2 fpn minus 1 minus minus of 2c minus 14, correct? Yes or no?
Yes, ma'am.
Everyone? Is this step clear? This one.
How two is came, madam?
Which one? This one?
Alpha is equal to 2 here. How this is beginning? Yeah,
In,
that one. Yeah.
so what we are doing? Okay, so if we take simple value, um, so probability of mode of z greater than some c, correct? So I can
Yeah.
write this as probability of z uh, greater than c plus probability of z less than c.
Okay.
Yeah, minus c. Okay, now this can be written as this is equal to what? Probability of z greater than okay, probability of z greater than c will be equal to probability of z less than minus c. Yes or no?
Mm.
The probability is like if you
Yes,
just
yes. Yeah.
normal, yeah, in a normal.
Yeah.
So I can write this as 2 into probability of z less than minus c.
Okay.
Yeah,
Okay.
and this is what 2 into fz, right?
Okay. Got it.
Yeah, do the same thing. So we did the same thing here as well. Fine. This step is clear now.
Yes, madam.
Everyone, can I get a thumbs up? Okay, fine. Now this is 0.05. This is 2 ftn minus 1 minus 2 c minus 14. Now this will get divided, so this will be 0.025 f t by 35 minus 2 c minus 14. So now this will be what? F inverse of 0.025. Yes or no? Till here, is it fine to everyone?
Yes, ma'am.
Okay. Now this is what? Minus 2.03, right? Now you have to find the value of c. So c will be what? Minus will get cancelled. So this will be 2.03 divided by 2 plus 14, right? Yes or no?
Yes.
Yeah.
Yes, ma'am.
So now this value is coming out to be, can you guys calculate?
15.015.
0.03 divided by
15.015.
2 plus 14. So this is 15.015. So this is 15.015. Now C value is this. Now what is, so my rejection region is what? If my mod of T is, this was the rejection region, right? Mod of T is greater than C. Now my C value is 15.015. What is mod of T? The sample mean. And what is my sample mean?
Madam, this F value they provided us
Yeah, this value will
0.025.
be provided. Yes. So what is my T here? Can you guys tell me?
Okay. Okay.
14, right?
What is T?
Oh, okay, sorry, 15.5.
Yeah, so this will be 15.5. So my mod of T is coming out to be 15.5. So is it greater than this value or less than C?
It's greater than C.
It is greater than C. So what would I be doing? Will I be rejecting or accepting the null hypothesis?
Reject.
So we would be rejecting the null hypothesis. Is the solution clear to everyone?
Yes.
Sure. T-test is clear? Now
Yes,
you
sir.
got the point how to do T-test. Now is it clear, right?
Yeah.
Yes.
Yeah. Okay, fine. Now let's do the second question. Now,
In this, madam, sorry to interrupt. In this case, if not provided, not equal to means instead of greater than less than, then we will not use mod, right? So
no. Then you won't be using mod, right? Then my
yeah,
rejection region would be what? It would
one-sided,
be
right?
T
One-sided.
greater than C or T less than C. Okay?
Yeah, any one of them it will come, right?
It depends upon your alternative.
Okay, okay.
Okay, let's move to the chi-square test. When do we do chi-square test? Anyone?
Sigma square is unknown.
No. No, for what we do chi-square test? For what? For
Or
to test
variance.
what? For variance,
Or
right?
variance.
Yeah, I was just asking that only. So here we have X is following
The
a
sample variance.
sample variance. So here my X is following a normal distribution with unknown standard deviation sigma, and my N is 25 IID samples of X. The sample standard deviation is 5. What conclusion would a chi-square test reach if my null hypothesis is this and alternative is this at a significance level of 0.05? So here, my null hypothesis is what? Sigma equals to 4. And my alternative is what? Sigma is greater than 4, right? So this is a right tail test. Yeah. My N is what? 25. And my sample standard deviation, that is my S, is given to be 5. Now, what is my, the first step is this. My second step is what? The test statistic. What will be my T here?
T is equal to S square.
Correct. My T is S square because we are testing for the sample variance. Now, third, what is my test here?
Reject null hypothesis if S is greater than C.
S
S
square
square
is
is
greater
greater
than C
than
X,
square.
yeah,
square.
X square
Yeah,
is greater than.
we can write S greater than C as well. Okay. Now, fourth step, we will be finding the value of alpha, which is probability of
N minus 1.
no, just tell me what is the first thing. First step. It will be
Reject H naught.
S square
S
greater
square
than
C
C
square given sigma equals to 4. Correct? Now, which what is my chi-square distribution? What is the equation of a chi-square distribution? It is
N minus 1. S square by sigma square distributed chi square N minus 1.
okay. So what I would be doing? I would be multiplying and dividing it by n minus 1 and a sigma square. So this will be n minus 1 s square divided by sigma square greater than n minus 1 c square divided by sigma square. Okay. Now, in place of sigma square, what I would be writing?
5 square.
4 square.
4 square, right? So
4
this will be
square,
16. And what is my n here?
25.
N is 25. So this will be what? 25 minus 1? 24 c square. Correct? Till here it's fine?
Yes.
Okay. Now this, I can write this as 1 minus f chi square with 24 degree of freedom, 24 c square divided by 16, right? This is my 0.05. Yeah?
Yes, ma'am.
Yes,
Okay.
ma'am.
Now this will be what? My f chi square 24 degree of freedom 24 c square divided by 16. This will be what, 0.95?
Yes.
Yes or no? Yeah.
Yes. Yes.
Now, this will be what? F inverse of
Inverse.
0.95. Now, this will be chi-square distribution. So, the value of chi-square distribution is given to be
36.41.
36.41.
Yeah.
So, this is 36.41. Now, what will be my c square? C square will be 36.41 into 16 divided by 24. So, my c square will be, calculate this value.
24.27.
Sure.
Yes, ma'am.
24.27. So my C square value is 24.27. Now, what was my rejection region? If my S square is coming out to be greater than C square. What is my value of S square? What is S square?
5.
It's
5.
25, right? Yes,
It's
it's 5.
25.
Yeah.
It will be, because S is given to be 5. So what is my S square? It will be 25. So this is 25 and my C square is 25, 24.27. So is it greater than or small?
Greater than.
Greater
It
than.
is than.
Greater
So what
than.
I would be doing?
We'll reject H
Reject
naught.
the H0.
We will be rejecting H naught. Is the solution clear?
Yes, ma'am.
Like ma'am, in solution, we will compare with the variance, given variance 4 greater than 4, and when we see in the last, we will see the given sample standard deviation.
We will be, because we are, by test statistic it was the sample variance, right? So I will be comparing my critical value with the sample variance, right?
Yes.
So is the t-test and chi-square test fine to everyone? Is it clear how to solve it?
Yes, madam.
Okay.
Yeah, as of now, it is okay, ma'am. But
Yeah.
need to practice a lot, otherwise we'll
Yeah,
forget
you
all.
have to practice a lot, because here they are actually telling you which test you have to use. But in the exam, they won't be telling you which test you have to use. You have to see, like, according to the situation. Okay. So when I would be using t-test, if I have unknown variance, right? Unknown variance, and I would be testing for the sample mean. And when I would be using chi-square test, if I have to test for the sample variance. Okay. These are the two conditions. So you have to remember the condition. In which condition I have to use which test. And you have to remember this equation as well. Okay?
Yeah.
Yeah. Now, we have the
Ma'am, the chi-square test is only for sample variance, or
variance.
sample standard deviation can be tested.
We are testing for the sample variance only.
Okay, so we can't use that for sample standard deviation. Yes, sir.
Sample standard we can do, like we were the test statistic was C, S greater than C, right? What was my S? S was sample standard deviation, right?
Yes, ma'am.
So it's the same thing. So we, like in place of S, we are using S square.
Okay.
Okay, now you guys tell me by reading this question which test I have to use. We have a sample of 30 boys who has average marks of 70, a sample of 15 girls who has an average marks of 75. Is the data enough to conclude at a significance level of 0.05 that the marks of both boys and girls are the same on average? Assume a standard deviation of 15. Now tell me,
Ma'am, Z test.
Z test, ma'am.
why you are using Z test?
Because
Ma'am,
we
because
have
the given value,
Because
we have the value given FZ inverse.
no, because we have standard deviation of 15. So it
yeah,
is
correct. We have a known variance here. That's why we are using the Z test. This in the exam you won't be getting under the question, you won't be getting the values that you have to use. Okay. So only read the question. So from the question only, you have to see which test you have to use. Okay. So here I have been given the value of the variance. So if I have the value of variance and I need to calculate I need to test the average, the sample mean. So I would be using the Z test. Got the point?
But ma'am, in last question we have seen last example. In that also standard deviation was given.
In the last question,
Yes.
where is it? We have unknown standard deviation.
But the sample standard deviation is 5.
Yeah, but for what we are testing, what is my alternate null and alternative hypothesis?
Is sigma greater than sigma greater than 4.
So we are actually testing for what?
Sigma.
Which is variance or standard, which is variance and sample or sample standard deviation, correct?
Oh, okay.
Yeah, you got the point. Here, what is okay? Now you guys tell me what is my uh, null hypothesis.
A small question. So,
Hmm.
so here when they say standard deviation of 15, is it the sample standard deviation or the population standard deviation?
This is the population standard deviation.
Ah,
If
okay.
they are mentioning sample,
Okay.
they would be mentioning sample standard deviation if it's for the sample.
So in the previous question as well, population was unknown,
Was not
and then
unknown.
sample
Sample
standard
was
deviation
given.
was yes, which
Yes.
was given. Okay.
Yeah.
Okay.
Okay. Now you guys tell me what is my null hypothesis here. For a two sample Z test, what was my null hypothesis?
mu1 equal to mu2.
Mu1 equal to mu2. And what was my alternative hypothesis according to this question? So null hypothesis
mu1 unequal
to
mu2.
mu2. Okay. So my null hypothesis would be that the average of both boys and girls are same, and alternative would be they are different. Okay. Now the second step. What would be my test statistic?
Mean. Sigma.
Reject null hypothesis
No,
when
I'm just asking
alternative
about.
hypothesis is true.
No. I'm asking about test statistic. What x bar minus y bar?
Difference of sample
The
means.
sample.
Sample means.
Now, what will be my t here? The test here? Reject h naught if
X minus Y.
x minus y.
X minus Y is data enough to control the signal.
So what is my alternative? mu1 is not equal. That means it is a two-tailed test.
Right.
Okay, this is two-tailed test. So this is what? Mod of t greater than t.
Yes.
Yeah. Just remember one thing. If I'm having a if I'm having one tail test, if I'm having right tail test, I would be having the alternative as
P is greater than C.
greater than some mu
C.
is greater than some value, right? So my test would be what? That my t will be greater than c. Similarly, if I'm having left tail test, so my alternative would be what? Mu is less than mu naught, and my test would be rejecting h naught if my t is less than some critical value.
C.
If I'm having two tail test, so my alternative would be what? Mu is not equal to mu naught, and my test would be rejecting h naught if
Mod T is
greater than.
greater than C.
Fine. Is this thing clear? So you just have to see what is your alternative. If mu is greater than c, my rejection region would be t is greater than c. Okay. If mu is less than mu naught, it is t less than c. If it is two tail, it will be mod of t greater than c. Is it fine? Yes or no? Yes or no? Okay.
Yes.
Now reject h naught if t is greater than c. Now the fourth step, what is my alpha? Alpha would be probability of
Mod of t greater than C.
given H naught.
Given
H naught given
mu1 equal to mu2.
mu2. Now, I have to convert this into a Z test. So this will be what? T minus
Mu1 minus mu2
uh,
divide by under root of sigma 1 square by n1 plus sigma 2 square by n2.
this will be following normal 0, comma 1, right? Now, this will be what? Probability of. Now, here my mu1 and mu2 are equal. So, this will be 0. So, I can write this as T divided by under root of sigma 1 square n1 plus sigma 2 square n2. Correct? Yes or no?
Yes, ma'am.
Okay. Now, my what is the value of sigma here?
$15.
It is 15. So the standard deviation for both that sigma 1 and sigma 2 are same. So I can write this as probability of Z mod of Z greater than T divided by this will be 15 under root 1 minus what is N1?
30 and 15.
30 and 50. So this will be 30 plus 1 by 50. Okay. So now this, okay. So this will be probability of mod of Z greater than what will be this value? This will be C under root 10 divided by 50. Okay.
Ma'am, like, why are we taking sigma 1 equal to sigma 2? Like, can we generalize that? Because in the
No,
question,
because in the question it is saying that assume a standard deviation of 15. So that means the standard deviation for both of the samples are same.
Okay.
Otherwise, they will mention it the different samples if they have the same different sample standard deviation. Okay. So this is my value. Now, alpha can be written as
One minus
this is written as 2 into z minus c under root 10 divided by 15. Yes or no?
yes, we can write.
Okay. So what is my alpha? Alpha is 0.05 to sz minus c under root 10 divided by 15. Now this can be written as 0.025 equals to fz minus c under root 10 divided by 15. Now this is what? Minus c under root 10 divided by 15 equal to fz inverse of 0.025. Correct? Till here is it fine? Yes or no? Okay. Now, what is my value of SZ inverse? 0. Which is minus 1.96. So this is minus C under root 10 divided by 15 minus 1.96. Now, what is the value of C? Minus 1.96 into 15 divided by 100 root 10. You guys calculate and tell me the value.
9.3 approximately.
9.3. Okay. Now, what was my test? I would be rejecting if my when I was rejecting. Yes.
Modulus of t is greater than c. So we want to calculate t, right? From the sample.
Yeah. So this will be mod of t greater than 3. Now, what is mod of t? Mod of t is basically mod of x bar minus y bar.
Yes, ma'am.
So what is x bar? Has an average of 70
and 75.
and 75. So this is 70 and 75. This is mod of 5, correct? So that means my value of mod of t is coming out to be 5 and my value of c is 9.3. So my 5 is less than 9.3 or greater than 9.3?
Less than 9.3.
It is 9 point. Okay. So are we going to reject or accept the null hypothesis?
Accept the null hypothesis.
Okay, we will be accepting the H naught. Got the whole point? Got the whole solution? Everyone?
Yes, ma'am.
Yeah? Okay. This is how you do the two sample Z test. Now, the last question. An instructor handles two classes A and B for a particular subject. So that means it's a two sample test. In an examination, standard deviation of marks of 16 students from class A is 9, while the standard deviation of marks of 25 students from class B is 12. Can we conclude a significance level of 0.05 that the standard deviation of average marks of both of the class are same? Okay, which test we would be using here?
This is t-test, ma'am.
How is this t-test?
Okay, ma'am. This appears to me as a Z test only, right? Because standard deviation is given. I mean, variance is already given, so it's a known variance case, right?
No, but here we are testing for standard deviation, right?
Okay.
Which test?
Standard deviation is.
Ma'am, it has to be F test because we are given with the standard deviation of the samples, which are nothing but S1 and S2.
Yes, correct. So actually the first thing is we are testing for the variance and it's a two sample test. For two sample test and if we are testing for the variance, we would be using the F test. Got it? So my first thing is what will my null hypothesis will be?
F test.
So this is what, see, we have been given the standard deviation
Sigma
of
1 equal to sigma 2, right?
sigma 1 equals to sigma 2. My alternative would be
Not equal. Sigma 1 not equal to sigma 2.
correct. Now the second is what is my test statistic?
S1 by S2 the whole square.
Sx square divided by sy square. Correct? Now third, what is my test?
If t is greater than 1 plus CR or t is less than 1 minus CL.
Correct. Now we will be calculating alpha by 2, which is probability of P greater than 1 plus CR, or alpha by 2 probability of P 1 minus CL. So the first thing is, if you see here, what is my value of Sx square? Or you can say Sx. It is 9, correct? First, or let's say, let me just say A. And for B, it is
12.
It is 12. So if you see here, my value of SA divided by SB would be less than 1 only. If I divide.
Yes, ma'am.
Yeah. Okay. So what I would be doing, you have to see if my the thing is, you have to check whether I have to use 1 plus CR or 1 minus CL. So if my value of this division is coming out to be less than 1, so I would be using this value, which is the left hand side. Okay. Is it fine? Yes or no? Okay. Now, my alpha by 2 would be what? Probability of P less than 1 minus CL given my H naught is true, right? That is sigma 1 equals to sigma 2. Okay. So, now, this is what? Alpha by 2 equals to? I can write this as F distribution with what are my degree of freedom? What is the degree of freedom for A?
F n1 minus 1, n2 minus 1.
Yeah, it is n1 minus 1, comma n2 minus 1. So this is my degree of freedom, correct? Okay, you have to remember this first degree of freedom will be the degree of freedom for the numerator, and the second degree of freedom will be the numerator of the the degree of freedom for the denominator. Okay, you have to just remember that. Okay, so n1 minus 1 comma n2 minus 1. So I can write this as f. What is n1?
16.
16.
16, right? So my distribution for the numerator part will be what?
15.
Okay, and denominator?
I think it's
24.
24. Okay, so this is 1 minus CL. Now what is alpha? 0.05. So this is 0.05 divided by 2 equals to F 15 comma 24 1 minus CL. So first you have to calculate the value of 1 minus CL. So I can write this as 1 minus CL equals to F inverse of 0.025. Correct? Yes or no?
Yes, ma'am.
Yeah. Now this will be what? So this value is what according to the hint? It is given to be 0.37. So you just have to see which value you have been given. So this is F inverse of 15 comma 24. In the exam, it can be written as F inverse of F 24 comma 15. So you have to remember which value you have to take. Okay. So this is 0.37. So this is 37. So my 1 minus CL is coming out to be this value. So now what is my test? Test would be
T less than 1 minus CL.
CL. So what is my T? T was basically
Sx square divided by Sy square.
okay. Now can you calculate this value?
16 by 25.
Why 16 by 25? What is
Or
the variance of for A
15. Oh,
81, right?
and for B?
981.
144.
144. So if you divide this, what is the value that you are getting?
0.56.
0.56. Okay. Now, this is 0.56 and this is 0.37. So less than or greater than?
Greater than.
Greater
Greater
than.
than.
So will we be rejecting or accepting?
Accepting.
We would be accepting. Is the question clear to everyone? The F test.
Ma'am, like if sigma has given, we'll use F test.
Sigma is given.
If sigma is given for the both A and B, like
I mean, if you can just highlight what are the tests that is there in the syllabus and what is the major difference between those two. I mean, those then that will be good. Like Z test is a known a sample. For T test, we understand. If you can just help us to differentiate one more time, it will be of a great.
So for that, you have to just tell me, like, because I'm not getting the point when you are getting stuck, right? Because nobody is saying anything. So now you have to tell me which test you are like finding difficult. Okay. So I'm just going one by one test. So the first test is I have Z test. When I would be using Z test?
Z test when we know the sigma.
when known variance.
And we are testing for what?
Sample mean.
We are
Mean.
testing for the sample mean. Okay. That is X bar. Now what will be my T here? T will be my X bar and Z will be equal to what? X bar minus
Mu
Mu.
divided by sigma.
that's it.
Yes,
Yes.
this is very good. Yeah.
Sigma by under root n.
Yeah.
Okay. This will be Z. Now, second, I have the T test. This is done
T test when it is unknown sigma.
we have unknown variance. What will be my T here? T will be X bar. So these both t-test and these are for sample mean. Okay. So if you're testing for sample mean, my t would be equal to X bar. Now for this case, what will be my test statistics? It would be X bar minus
mu naught by sigma by under root n.
sigma is unknown.
Yes.
So if sigma is unknown, what I would be using? S divided by under
Yes.
root n. So this will be
Yes.
following t n minus 1 degree of freedom. Is Z and t clear? We use t test when we have unknown variance and we use Z test we have known variance. Is this fine? Z,
Yes.
this will be following Z distribution, normal distribution with 0, 1, and this will be following t distribution with n minus 1 degree of freedom. This two test is clear?
Ma'am,
Yes, ma'am.
sigma is like standard deviation and S is sample
Sample
standard
standard
deviation.
deviation. Okay. Okay. Now we have chi-square test. When do we use chi-square test? For testing
When
the
When mu is
for
given
for testing the sample variance. Okay. Now here my t would be what?
mu1
S
is
square?
n minus 1 s square by
No. I'm just asking the test statistics. T
yeah.
would be sample variance.
S square is greater than C square.
So that will be my test for that I will be rejecting t is greater than c or less than c or somewhat. Right. Now what? Which value will be following chi-square test? What is the equation? Value
Chi-square test.
n minus 1 s square divided by sigma square.
this will be
Which
following chi-square with n minus 1 degree of freedom. Okay.
Yeah.
So this is to test for the sample variance if we are having only one sample. Now we have the F test. When do we use F test? This is for the sample variance only. But if we have two samples. Okay. Now here my T would be what?
X square divided by sy square.
Okay. And what will be my F distribution? Sx square divided by sy square will be following my F distribution with n1 minus 1 comma n2 minus 1 degree of freedom, right? Yes or no?
Yes, ma'am.
Yeah. And
Yes,
we
ma'am.
would be, so my test would be rejecting H naught if my T is greater than 1 plus CR and T is less than 1 minus.
minus CL.
Okay.
So, ma'am, this is with the degree of freedom f n1 plus n2 minus 1, right? I mean, just the previous step.
Which one?
I mean, just the second last step where f, you say n1.
Minus 1.
N
This one?
n1. Yes, this one.
This is n1 minus 1 comma n2 minus 1.
n1 minus 1. Okay.
Yeah. So this is the degree of freedom for the numerator part. This is the degree of freedom for the denominator part.
Okay.
So this chi-square test and F test we use for the variance. Okay. So if we have one sample, we use the chi-square. If we have two samples, we use the F test. Okay. And if we have for this sample mean, we use Z test and T test. Okay. So if we have a known variance, we use the Z test. If we have unknown variance, we use the T test. Fine.
Yeah.
Now is it clear a little bit?
Ma'am, just can you scroll up a bit, ma'am? I missed taking a note. Yeah, over there. So chi-square and F test is for variance. Okay, ma'am. Thank you.
Okay. And Z test for two samples is the same thing, X bar minus Y bar. So it's fine, right? That is also for the sample mean, but for the two samples. Now is it clear? The test and all, the solutions are clear?
Yes, madam. This was very good, very helpful.
Yeah.
Thank you.
Okay. What about others?
Clear, ma'am.
Clear?
Yes, ma'am, it's clear.
Everybody is doing like the graded assignment questions, right? I guess because of that only few people are there, I guess. Yes or no?
Today is the last day.
Yeah,
Yes,
today
ma'am.
is the last day I got it. I thought it's fine. So week 12 is clear to everyone how to solve it and how to do the questions. So just remember, read the question carefully and check whether we are finding out for what test we are doing it. And like if it's we have been given the known variance and we are testing for the sample mean, we will be doing which test?
Sample mean the first two, Z and T.
Z and T. Okay. If we have known, we have used Z, and if we are unknown variance, we have T test. If we are testing for the sample variance, if it's a one sample test, we use the chi-square. If we have two sample tests, we use the F test.
Yeah.
Clear?
Yes,
That's
ma'am.
it. Okay. So now week 12 is clear. Everyone?
Yes, ma'am.
Yes, ma'am.
Okay, fine. So any doubts or anything?
Ma'am, one small theoretical question, not based on the formulas or the problems. So basically, when we actually write in the case of two sample test, uh, 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 like for example, let's take the F test. There we have four different parameters, like for example, sigma 1, sigma 2, and S1, S2, or SX, SY. That's what we saw. So basically, what's the difference between the sigma X and SX?
Sigma is like the population, right? We have a population
So
variance, and S is
then,
the sample variance.
then so SX and SY, it's clear. But when we say sigma X and sigma Y, shouldn't they be same because we are taking the samples from the same population? So sigma X and sigma Y should always be the same, right?
No, the population variance is a different on sample, right? From the population, we are taking on different samples. So for the different samples, we will be having some different kind of sample variances, right?
Okay, so SX and SY are different. Yeah, that's clear because the samples might differ. But sigma X and sigma Y, these are population or sample based, or not clear for me actually there.
These are, yeah, so we denote the population sample variance and samples. We denote the population variance and population standard deviation with sigma. Okay,
Okay,
and
okay,
the sample thing we denoted by S.
okay. Yeah, correct.
Hmm.
So for the so even though we take the two samples, they are from the same population, which means there should be only one sigma, right? Why are we having sigma X and sigma Y as two different variables or two
No, no,
different?
sigma X and sigma Y are two different samples. Oh, sorry, two different populations, right? Sigma
Oh,
X is the X variable for the X population, and sigma Y is for the Y population.
oh, okay.
Hmm.
So the population is also different. So the
Huh.
oh, okay, two different
Okay.
populations, and we take samples from two different.
Hmm.
Okay, okay, okay.
Ma'am, just a basic doubt. Like while writing the hypothesis, we have to consider the population standard deviation, right? Like while writing null hypothesis, then it will be like sigma.
Because we are conducting the hypothesis, we are doing the test for the population only, na?
Yeah, okay. And for the test statistic, we have to
You
consider
know.
the samples.
Ah.
Okay.
The one who is
Yes, ma'am.
yeah,
Hello.
yes.
But, ma'am, what is the weekly distribution of the marks in the intern?
Weekly I can't say, but from 9 to 12 it's like I guess it's 70% something, 70 to 80% from week 9 to 12, and like 30 to 20% something from the week 1 to 8.
Please repeat. The voice was cracking in my phone.
Like I guess 70 to 80, like means I'm not sure. Like 70% of the marks are from week 1 to 12. Sorry, 9 to 12, and 30% I guess from 1 to 8.
Okay, ma'am. Okay, ma'am. And ma'am, from where we can access the document where you did this, means where you took the class? Will
No, this will be uploaded in the supplementary content by tomorrow.
Okay, ma'am. Okay, ma'am.
Yeah.
Can you share
Okay.
it now, ma'am? Because it will be easy for us to do the graded assignments. Maybe can you share it now?
Now, how can I share it? Because by tomorrow only they will be uploading this. Is there any other way I can share this?
Maybe Google Chat is or Discourse maybe.
Or Discourse, yeah.
Yeah, Discourse maybe.
This goes like today only. Okay, I'll just upload.
Yes. Thank you.
Yeah. Okay.
Old and all, where we can access, how we can access this draft and all?
Which one?
Now the class notes actually.
It will be in supplementary content. Now, in the supplementary content, there is a tab called live session. So in that live sessions only, you will be finding out all the PDF.
Okay, got it.
Okay. So anything else? Shall we end the week now?
Okay, madam.
Or
Thank
I
you.
guess I can ping the the PDF into the calendar. I guess I'll just do that.
Yes, ma'am.
Okay.
Thank you, ma'am.
Yes, madam. Thank you, madam.
Yeah.
Bye.
Thank you.
Thank you, ma'am, for the class.
Okay. Bye, everyone.
Thank you, ma'am.
Good night. Yeah. Okay. Bye.